All right, guys, I'm back with another chemistry video. All right, so hopefully most of you guys have already gotten through this, but if anyone is having a little bit of trouble with chemistry and elements, I do have this chemistry concepts Desmos practice. This is back in the week 1 folder. So if you come here to the second VidGrid and click over here, you can go to the student.desmos. You can continue without signing in. That's totally fine. Just write your name and go. And so this one is going to ask you how you're feeling about chemistry today. And you can see how everyone's feeling. Now we'll go next. All right, so next we're going to be using a simulation to explore atoms and symbols on the periodic table. So this is a really cool simulation here. It'll open up in a new tab. It's FET simulation. So if you go here, it says you can choose the symbol mode to start going through here. So when you go back to this tab, click symbol. All right, so we'll use the symbol mode, and it's going to show you this is the periodic table with all the elements, and then this is going to tell you a little bit about this symbol. I know this is not quite the way it's shown in the periodic table, but it still has some helpful information. And so we're going to go over here, and we're going to try to figure out what does this 4 in the upper left of the symbol represent. All right, it has like a little sort of scale over here, and so let's see, right now it says 0, so if we add a neutron, it goes up to 1. If we add a proton, it goes up to 2, right? But if we add an electron, it doesn't change. And so what do you guys think this might represent? Let's see, what are our options here? Our options are atomic mass, atomic number, or charge. All right. So, right, it's atomic mass. So this is going to be, that's what the measure here is for. We're measuring the atomic mass, right? That's correct. All right, next, we're going to look up here. This is the -1 on the upper right hand of the symbol. Represents what? So let's go back to our simulation. We'll look for this little symbol over here. It has this line pointer going from negative to positive, right? And so right now, we're 0. But let's see if we add more protons, right? That's going to change it to a +1, right? What charge are protons? Protons are positive, right? So we're adding positive charges. Here we have 3 protons. That means we have 3 positive charges over here. We have 1 electron. What charge are electrons? They're negative, right? So we have 3 positives and 1 negative, and so we have the 1 electron. This negative is going to cancel out one of these positives, so we have 2 positives left. So this is going to be charge. Okay, so this is going to be counting our charge, right? So if we wanted to add a neutron, right? What are neutrons? They're neutral. They're neither, right? So it doesn't change the charge. And so if we wanted to go ahead and add some more electrons to get it to a neutral atom, right? So then we have 3 protons and 3 electrons, and it's neutral. All right, and so if we add another proton, right, it's going to change to positive over here. The other thing we notice is as we're changing the number of protons, notice that it's changing the name. Here it's actually changing which element that we have, right? And it doesn't, the element doesn't change if we change the electrons or the neutrons. It only changes if we change the number of protons. All right, but see, let's go back to here. We said, so this one up here is indicating the charge. All right, so next we have the 2 down here, the lower left, the symbol. What does that represent? Remember this one here. Okay, well, when does this change? So this changes when the name changes, right? It changes when the number of protons changes, right? And so this is going to be, we only have one option left. It's the atomic number, right? The atomic number is the number of protons, and it's also going to be telling us what elements is. So this represents which element it is. All right, so now if we build this atom, lithium over here, if an atom has 3 neutrons, 3 protons, and 4 electrons, what would its atomic mass be? All right, so we can go ahead here and we can build it. We have 3 neutrons, make 3 neutrons, and we can see up here how many there are. If we have 3 protons, right, and 4 electrons, so let's see, 1, 2, and we have 4 electrons here. So this is what we have to build. So we can look here and see what the mass is. The mass is 6. So how do we get that mass? Remember, the atomic mass is going to be the number of protons plus the number of neutrons, right? So if you go back to our chemistry introduction, so protons weigh 1 atomic mass unit, and neutrons weigh 1 atomic mass unit. And electrons, though, they're tiny. They weigh like almost nothing. They're kind of negligible, so they don't even really count. And so we count the numbers of the protons plus the weight of the protons plus the weight of the, or mass of the protons plus the mass of the neutrons. It's going to equal our atomic mass, right? So we have 3 protons and 3 neutrons, that equals 6 total, right? And so our atomic mass here is going to be 6. So, right, it is the protons plus neutrons, right? And so I've done this in other sections, and so there will be some other students that have answered, and all the names are anonymized. And you'll see what some of their responses were too. All right, so if an atom has 3 neutrons, 3 protons, and 4 electrons, what would its charge be? All right, so here we can see, if you jump to your build an atom, it says it's a negative ion, right? And it says here our charge is -1. Why? Right, so remember, we have 3 protons that are positive, 3 neutrons, they're neutral, so we don't have to worry about those, and then 4 electrons that are negative. So if we notice, these are going to cancel out, these protons and neutrons, but this electron, we have an extra negative electron, and so we're going to have a -1 charge. Right, and then you'll see what other students have said. All right, so this is a card sort. This one's a little bit more confusing. It'll take a little bit of time. So I recommend what you guys do is you go ahead and start the card sort. And you can use the simulation to help, pause the video, and then work on the card sort as you go. All right, and so once you are working on the card sort, you're going to be, these are the big cards. We're going to do always, sometimes, or never. And so I'm going to give you a second, pause, work on the card sort for a little while, and then once you unpause me, then we'll kind of go over the answers. All right, so adding or removing protons changes that atom's atomic number. So remember, the atomic number is the number of protons, so that's always going to change that atomic number. All right, adding or removing electrons changes the mass of an atom. So how much mass do the electrons have? Right? They are like, oh, they're very negligible. They hardly weigh anything. So this does not change the atomic mass. Okay, let's move this around. All right, adding or removing protons changes the mass of the atom. So remember, what is the atomic mass? The atomic mass is the protons plus the neutrons. So if we change the protons, are we going to change the mass? Yes. All right, that's always going to change the mass. All right, adding or removing electrons changes the charge of the atom. So if we just are adding and removing electrons and not the protons also, right? So let's say we had a neutral atom and we take away an electron, then it would become positive. If we had a neutral atom and we added an electron, it would become negative. That would be an ion. So yes, it does. All right, adding or removing neutrons changes the atom's mass. So once again, this is going back to remembering that mass is going to be protons plus neutrons. So that will change the mass. All right, changing the atom's atomic number changes the element of the atom. Remember, the atomic number is, and we can go back to here, so like the atomic number is the number of protons, that changes the number, and remember, the name is always going to change too. So you can always use this to test those things, right? And so when we're adding the protons, it's also changing the mass. So let's see. All right, adding or removing neutrons from the nucleus changes the charge of the atom. All right, so let's see. We're adding or removing neutrons, and we're looking at the charge. Does it change? No, the charge does not change. Oh. Let's go back to here. Does not change. Adding or removing neutrons can make the atom unstable and radioactive. Let's see. Let's go to build an atom, and we're going to click this, stable or unstable. Ah, this is unstable, right? And so sometimes if we add or remove neutrons, sometimes it makes it stable and sometimes it doesn't. So this is going to be like a sometimes one. Also the same with protons. If we change the ratio of the protons to the neutrons, then we may have, that affects if the element's stability. All right, so that's going to be a sometimes. All right, adding or removing some protons and some electrons changes the charge of the atom. Well, let's see. If we have right now a positive 2, if we remove 1 proton and 1 electron, it doesn't change, right? But if we take away just, 2 protons but no electrons, then it does change. So That's going to be a sometimes one because this one, it depends on how many that you're removing or adding, right? So you just have to be more specific. Adding or removing neutrons changes the atom's atomic number. All right, so let's look. The atomic number down here is 4. If we add or remove neutrons, it does not change the atomic number, right? All right, so 2 cards left. 2 atoms of the same element can have different atomic masses. All right, let's check this on our simulation. All right, so this is beryllium, right? This is the element beryllium, and this is the atomic mass of 12. So what if we remove a neutron? Now it has an atomic mass of 11, atomic mass of 10, but these are still beryllium, so that's true. So they can. 2 atoms of the same element can have different atomic masses. I'm going to put that in sometimes because I guess they can, but they can also have the same. They may also have the same. All right. Adding or removing protons changes the charge of the atom. All right, so if we add or remove protons, right now we're at +1. If we add another one, it goes to +2, +3. If we remove them, that's also changing it. So yes, that does change the charge. So that always changes the charge. Oh. All right, so this is a really cool little simulation that hopefully can help you understand a little bit more about atoms. Let's keep going. A couple more questions. All right. So this is going to be, if you went over the chemistry worksheet before, this is kind of similar. So it says, for the given element, fill in the table and draw the electron shell diagram. Be sure to include the number of protons and neutrons in addition to the correctly placed electrons on the electron shell diagram. The innermost shell can hold 2 electrons and the next shell can hold 8. They fill closer to the nucleus first. So this is sodium. The atomic number is 11, so that we know that's the number of protons. We're going to assume it's a neutral atom at the start. So we're going to say that it must have an equal number of protons and electrons. And now the 22.99 is going to be the average atomic mass. So on the periodic table, you see this average atomic mass. And that would be like most of them have like 23 is the atomic mass, but a few of them have 22, right? Remember, they can have a different number of neutrons. So if I gave you this, you could round it, right? And so we're going to round 22.99 to 23. So we're going to say the atomic mass is 23. So if we know the atomic mass is 23 and the number of electrons are 11, what would the number of neutrons be? All right, so you're going to do 23 minus 11, right? It's going to be 12. If I did the math right. All right, and so then we would have 11 protons and 11 neutrons. They would make up the nucleus. And then we're going to add our electrons. So remember, we had 2 electrons first here. 1, 2. And then that's going to be the innermost shell. And then we can have 8 on the next one. 1, 2, 3, 4, 5, 6, 7, 8. Right, so that's 10 total, and then we have to have 1 more on the outside. Oh my gosh, that's really ugly. Here we go. That's our 11th electron. So that's kind of what it should look like. It fills towards the innermost shells fill first. All right, so now we have chloride. So we're going to do the same thing with chloride. So we can either decide when we round this, we can either round it down to 35 or up to 36. It's a little lower, so I'm going to round it to 35. You should be able to do the calculations either way. It'll just change the number of neutrons. All right, so we know that the number of protons, again, is going to be 17 because that's the atomic number. And we're going to say the number of electrons is the same because we're assuming it's a neutral atom. And then down here, we're going to figure out that 35 is the mass number. And so 35 minus 17, right? So you can either do that in your head or you can pull up, you know, a handy-dandy calculator, maybe. Right, and so we got our calculator, and we're going to go 35 minus 17 equals 18, right? And so that means we have 18 neutrons. And so now how would we put this on our, make it real big. So we're going to put it on our diagram here. And so once again, we have these 2 are going to start on the innermost, put them next to each other if you want to, together, like a pair. Then we have 1, 2, 3, 4, 5, 6, 7, 8. So that's 10 total. So we need 7 more. 1, 2, 3, 4, 5, 6, 7. So if you notice, there's not a full outer shell here. This one only has seven in the outer shell. These, remember, they want to have 8. They want to have full outer shells. So either the innermost one wants to have 2, or the outermost ones want to have 8. So this one really would like one more electron, if possible, to have a full valence shell. All right, so hopefully that helped a little bit. You can let me know how well did you understand chemistry today? How did you feel about learning chemistry? Now I understood it, but I didn't like it, or so on. And then you can say something else if you want. All right, so hopefully that simulation and the card sort help. Let me know if you have any questions. Thanks, guys.